Good day, guys. Let's look at one more problem on partial fractions. So our starting point will always be the same. You look at the degree of the numerator, it's a 2. Denominator, if you expand this, you get x squared. X squared will multiply that into x cubed, which means x squared is smaller than, or let's say 2 is smaller than 3. So this is a proper fraction, and there will be no need for partial fraction, for long division. We only do long division for improper fractions. So we're going straight to our partial fractions. So I'll get a on 3x minus 1 plus b on 3x again minus 1, all that square until I exhaust that power, because this is a linear term repeated 2 times. Then finally I can take a c on 2x plus 3, because that's another linear factor. So if you're using your formula sheet, you might be taking a d on 2x plus 3, but a, b, and c, and a, b, and d, they're more or less the same thing. But then you must calculate the constant. So then start our procedure. On the left, we'll get 3x squared minus 7x plus 6, which we get by using the LCD to divide itself. It gives 1, we multiply there. Then if I switch to the right, if I divide LCD here, you see that 3x minus 1 will take out 1 of that. So I get a into 3x minus 1 into 2x plus 3. Then plus, if I take this and divide them, 3x minus 1 square will take out itself. So I'm left with b into 2x plus 3. Then finally, if I take this to divide that side, 2x plus 3 will take care of itself. I'll get c into 3x minus 1, all that square. So that is what we get. Then it's time to get a, b, and c. So usually when I find myself with only linear factors, for me the fastest means is to choose 3 different numbers. Since this is a linear factor, it's the same linear factor repeating 2 times a linear factor, which for any 6 students, that will be the second formula on page 6. Each time you use that formula, the fastest thing is to choose numbers. So I will choose 3 numbers. The first one will be 1 over 3. I'll say if x is equal to 1 over 3, if I equate that 1 to 0, then I substitute it all through. So I will do that on the left and on the right. So 1 over 3 square is 9, 1 over 9, so I get 33 on 9. Then 1 over 3 times 7 is minus 7 over 3. Then plus 6. So the left gives me 22 over 3. So on the left I get 22 and 3. On the right, if I substitute 1 over 3, since it came from here, this will be 0, that will be 0. Then I'll put 1 over 3 there, it will be 2 over 3 plus 3, 3 plus 2 on 3. That gives me 2, is it 2? So the 3 plus 2 on 3, that gives me 11 over 3b. So you see that if you simplify this, it will give you b is equal to 2. Since the take care of 3, we just divide by 11. So b is equal to 2. Then our next number should be x equal to, if you equate that to 0, you get negative 3 over 2, which will also substitute right through. If I take 3 over 2 squared, that gives me 9 over 4. So I'm getting 33 times 9 on 4 for my first term. Then 9 on 7, negative 7 times negative 3 is 21 over 2. So it's plus 21 on 2. Then plus 6. So the left for me is 363 over 4. On the right, negative 3 over 2 comes from 2x plus 3, so this is 0, this is 0. Then I'll put my negative 3 over 2 there, times 3, that's negative 9 over 2 minus 1. So if you take negative 9 over 2 minus 1, that gives you negative 11 over 2. If you square it, 11 squared is 121, 2 squared is 4, c. So again, 4 will take care of 4, so you'll simply be taking This is 3 divided by 1 to 1, that gives you 3. So it shows that C is equal to 3. So now that we've exhausted all the numbers, you have to choose one last number, and you can choose any number of your choice. If you're a smart person, you just choose 0. You must choose any number that is different from the ones. You can choose anything you choose is fine. So if I choose 0, the left side will be a 6. The right side, there is 0 here and 0 here, I get negative 3a. So that's negative 3a. If I put 0 here, I get 3b. But can you see a b? A b is 2. So 3 times 2 is 6. If I put 0 here, I get 1c. Our c is 3. So here, this will be telling me that if 6 comes here, it cancels. So I get negative 3 is equal to negative 3a. And that shows that a is equal to 1. So we have succeeded to solve for a, b, and c. So I've used the technique of substituting numbers, but you could still have expanded and compared coefficient. I usually prefer that when I have linear factors all over the place, I substitute numbers. I feel it's a faster method if you are good with your algebra. But if you can expand, compare coefficient is still fine. So we can now go to integration. 3x squared minus 7x plus 6 divided by 3x minus 1 all that square into 2x plus 3 dx will be replaced by the 3 partial fractions, where I will be replacing my a by 1, b by 2, c by 3. So this is the integral of 1 on 3x minus 1 dx. Then my b is the integral of 2 on 3x minus 1 all that square dx. And then the last one, c, is the integral of 3 on 2x plus 3 dx. So those are your substitutions. Then when you are faced with this situation where your denominator is made up of linear factors that are repeating themselves, then you should know that the formulas we need here are the U substitution for a fraction, and you see there is a power rule. So we know those formulas. U substitution for the fraction. Format N6 is on page 4, the formula sheet. So that is what we need there. For the first and the last, you see the first and the last, they do not have powers. So that's why they match this formula. Why the other one is U substitution for a product, which we call it the power rule. So we must do those adjustments for our 3 problems, our 3 terms. So this is my U substitution for a product. So for the first and the last, I have to pass them through that formula. So let's go on with the adjustment. So if I go to the first, I copy my 3x minus 1, I put it there, just like the formula ones. Then I put the derivative at the numerator. 3x minus 1 you differentiate it, you get 3. Then you have dx, which if you match to the original, you see they are not the same because this 3 is not there. So I need a number outside that can take care of the 3, which is 1 over 5. Then if I move to the second, constants outside first, then this one has a power, so it matches the power rule. So to make it match the power rule, I have to take my 3x minus 1 up, so the power will become negative 2. Then the formula needs its derivative next to it. The derivative of 3x minus 1 is a 3 dx, which if I match it to the original, you see that this 2 exists. 3x minus 1 exists, the power exists, but this 3 does not exist. So I need a number outside to take care of the 3, and that is the 1 over 3. Then if I go to the last constants outside, then with this one, it goes back to U substitution for the fraction. So I will start by copying my 2x plus 3 there, just like the formula says. Its derivative must be at the numerator. The derivative of 2x plus 3 is a 2, which if I now match it to the original, you see a difference because the 2 does not exist. This 3 is there, 2x plus 3 is there. So I need a number outside to take care of the 2, and that number is a half. So with this, I've used those 2 formulas, which are on page 4 of the N6 question paper, to do my adjustment. Now I can write down my final answers, knowing that anything that went out must be in the answer. So this will be 1/3 the ln of 3x minus 1 for this one. It's using that formula. Then for this one, it is 2/3 outside. Then to write the answer here, the power of your f must increase by 1. So there you've got to write 3x minus 1. If the power increases, it becomes -1 or -1. Then for the last one, you get 3/2, the ln of, we're going back to this formula, 2x plus 3 plus c. So what is left is just to adjust that so that you don't have a negative exponent in your answer. So that is it. If you take 2/3 divided by -1, it becomes negative. The 2 stays at the numerator, the 3 at the denominator. 3x minus 1, we join it at the denominator. Then the last term stays exactly the way it is. So that is it, guys. I guess I've managed to touch everything that you need to know in partial fractions. Thank you very much.